In this video, we will learn about Fleming's right-hand rule. We have already studied that we can induce current in a coil either by moving it in a magnetic field or by changing the magnetic field around the coil. However, the more convenient approach is to move the coil in the magnetic field to generate an induced current in it. Now, it was found that the induced current was maximum when the direction of motion of the coil was right angled to the magnetic field. Now, in such situation, the direction of induced current can easily be determined by applying the Fleming's right-hand rule. So, Fleming's right-hand rule will be applied easily when the coil is moving perpendicular to the magnetic field. As per the Fleming's right-hand rule, we stretch our thumb, forefinger, and central finger of our right hand so that they are mutually perpendicular to each other, as you can see in this particular diagram. Now, in this mutually perpendicular situation, the magnetic field is given by the forefinger. So, the direction of forefinger gives the direction of magnetic field, whereas the thumb direction represents the movement of the conductor. Then, the middle finger or the central finger will give us the direction of the current induced in the conductor. Now, there are two types of current, that is direct current and alternating current. Now, depending on the magnitude and direction, electric current is classified into two categories. First one is the direct or DC current. So, it is an electric current which always flows in one particular direction and whose direction does not change with time. Okay, so it is a direct or DC current. Now, the current provided by a dry cell, a battery, a solar cell, or a DC generator is the direct current. Please remember this definition. You will learn more about DC and AC current when you go in higher classes. Alternating current basically is whose magnitude will continuously change with time and whose direction changes periodically after equal intervals of time. Okay. Now the current shown in the figure, that is this figure, that is this current. As you can see, it is fluctuating periodically with time. For half of the time, the current is in one direction, and for the other half, it is in reverse direction. So this is what we say an AC current is. Okay. Now, the current produced by an AC generator is an alternating current. In India, the alternating current is supplied at 50 Hz. Please remember this data. It is an important data. Now, thus the periodic time of AC will be given by 1 upon frequency, that is 1 upon 50 seconds. Okay, it means that in our household circuits, current changes its direction after every 1 upon 100 seconds. Okay, now what are the difference between alternating and direct current? So, the magnitude of current continuously varies with time in alternating current, whereas in direct current, the magnitude of the current remains constant. Secondly, the direction of current changes periodically. For the first half cycle, the current flows in one direction, and in the other half cycle, it flows in the reverse direction. But for DC, the current does not change with time. Okay, like this. If this is the positive axis, this is the negative axis, this is the time axis, and this is current axis. This is a graph for DC current, and this is the graph for AC current. Okay, current and time graph. Thirdly, the current obtained from an AC generator and main supply is AC, whereas the current supplied by cells and battery is DC. I hope this topic is clear to you. Thank you.